This demonstration is entitled Querying Cyclic Graphs. Now, a cyclic graph is a directed graph such that there exists a path somewhere in the graph where you go from a particular node and follow that path and you end up right back where you started from. Those are called cycles. Cycles are very, very difficult to deal with in relational technology. The classic way of traversing a graph is through the use of something called recursion. Now, if you use recursion in a graph that has cycles, what happens is you run into an infinite loop. The program never stops. What we're going to demonstrate here is TC-SQL's powerful support of transitive closure to enable you to query graphs that may have cycles in it.
In this demonstration, we show two windows. On the right, we show a PowerPoint slide. On the left, we show Microsoft SQL Server Query Analyzer. What we want to do in this demonstration is the following. We see a graph on the right here, and what we would like to do is implement this graph using relational technology. So we're going to use an object table here to represent the nodes of our graph. We're going to use an object connection table here to represent the connections of our graph. And we're going to use a transitive closure table here to represent the transitive closure of our graph here. So we're going to start out by executing 3 insert statements to create the nodes A, B, and C of our graph. And we see that here. So let's take a look and execute these 3 insert statements. We now want to create the connections in our graph, so connecting A to B and B to C. We have 2 insert statements here. The first one connects A to B via a connects to kind of connection. The second one connects B to C also through a connects to kind of connection. Okay, so I claim now we have inserted appropriate records to represent this graph here. So what we would like to do now is to be able to ask questions on this graph. And the question that we have in mind is the following. Given a starting node, we would like to report all of the descendants from that starting node. So if our starting node is A, we want to report B and C as being descendants. So let's look how to do that. So we have 2 ways. The first way uses our transitive closure table. In this case, it's using a view that contains use of transitive closure. Our starting position here is A, and what should be returned here is B and C, which we see, B and C. We have a second way of answering that question. It's through the use of something called common table expressions. This is a recursive call that, given our starting node, is going to return B and then recursively call itself to return C. So executing this statement here, we get B and C as expected. But what happens if we do the following? What if we modify our graph and now connect C to A? What we have now is something called a cyclic graph. Let's represent this connection here by executing insert statement here, connecting C back up to A. Okay, let's now ask the following query here. Let's change our starting node here. Change it from A to B. So now we're going to ask what are all the descendants of B. What should be returned are C, A, followed by B. So let's go up here and execute our select statement here. And sure enough, we get C, A, and B. Let's now execute our common table expression here. And when we do so, SQL Server dies because it ran into an infinite loop here, because it recursively called itself, continuing in this loop forever. It detected that and eventually bombed out here. So the lesson learned in all of this is through clever use of transitive closure, it is possible to traverse any kind of graph, including a graph that has cycles in it.